Okay, now in task C of the lab, what you need to do is that you need to implement the blink LEDs function, which I have shown you earlier in task B. You need to implement in an assembly. In this task, you are not going to download any new files. What you need to do is that you simply create a duplicate of the lab3 underscore b dot ino file and fat monitor underscore b dot s files and simply rename them as lab3 underscore c dot ino and fab monitor underscore c dot s file, and then create a new sketch which consists of these two files, lab3 underscore c and fab monitor underscore c dot s, right? So, and you need, what you need to do is that you need to implement the blink LEDs in assembly. How, I will explain, but you are not given any code. You need to do on your own, but I will explain how to do it in the video, so you can actually take help from the video. So let me go to the video. Let me close this one. Go to the lab 3C. Okay. So first thing which we need to let us start with the C file. So first thing what we have done is, like, in our C file, we have commented this code. Why we have commented this code? That because we don't want to read the data like gender, fat, and age of the person at this time point, because it will slow down in our programming. We will uncomment it again in the next task, but for now we are commenting it. Okay. The other thing is, like, everything else is same as in the previous file, but what we need to do, like in the part B, task B. But what else we have done is that we have already defined these variable, limit 1, limit 2, and limit 3 in the task B. I forgot to show you there, but it is already explained, defined there. Now let's have a look at the, and other than that, as we said that we are going to implement the function blink LEDs, so we need to also define it as an external function in the C. So we are mentioning it here. So we are telling the assembler that limit 1, limit 2, and limit 3 are the byte size variables. They are defined in the assembly file, and also we have a function blink LEDs which is also defined in the assembly file, but we are using these variable in this .ini file where we are using. So here, for example, we are setting the limit values, limit 1, limit 2, and limit 3. And where are we using the blink function? Here we are calling the blink function here, right? Now let's go to the assembly file and see, have a look at its code. So let's start from the top. So in the data section, we have already I have already explained in task A that we have uh, three variables which are made global, so that become visible to the other file, and these variables are gender, age, and fat. So these actually store the values which are received from the user. Then, other than that, we are defining three more variables, with the name of limit 1, limit 2, and limit 3. And we are also making them globally visible. Each one of them is 1 byte in size, and they are all of them are globally visible to the also to the other file lab3 underscore data ino, right? Also, we are defining some names, red, green, yellow, and all. So, and setting them to value of 0x0, 01, 0x10, 0x20, and 0x31. Why these values? Because remember what we said that to explain that why we are using these values, let me take you back uh, to this figure here. So actually, let me open Notepad, and then I can explain to you in the Notepad. So I am simply copying it, putting it in the Notepad. Now, if you go to the lecture one of our lecture one slides of this course, which can actually, I can go from here. So remember, we have a microcontroller and the board. Now the pins are different. So how we map the pins? So when we look, we can look at this table. So this table tell us like uh, this table tells us like if how the port B is connected. So the port B is connected, port B5, port B0 to port B5, pin B5, they are connected with D8 to D13. So we are going to use port B in our program, right? So we know port B0 is connected with D8, port B1 is connected with D9, and so on, and pin B5 is connected with D13, right? So, and also in our figure, how we have connected our LEDs, we have connected with pin 8, the red LED, pin 12, the green LED, and pin 13, the uh, yellow LED, right? So uh, now we know like if we have this 8-bit register or 8-bit port, which is now named as port B, right? On the AVR microcontroller, and it has 8 bits: 0, 1, 2, 3, 4, 5. And I'm not writing 6 and 7 because they are not connected on the board. So, but on the board, what pins I have on the on the board, what are the corresponding pins for this port B of the microcontroller? So port B0 is connected with D8, right? And this one is connected with D13, right? Now it's mean that D8 is basically here. So D8 is mean that with D8 I have connected the red LED. I'm writing R for it, right? And I have connected green LED at pin 12. Pin 12 is port uh, B pin number 4, right? So here I'm writing green, only G for green. And then I have connected yellow at pin D13, which is port B5, fifth bit of port B, right? Now, what I'm doing is that if I want to uh, turn on, if I want to like blink only, let's say red LED. So what I need to do is that I need to write on this port the value of 1, 0, 0, 0, 0, 0, 8-bit value. So I put two more zeros. So when I convert it to hex, it will become 0x 0, 1, right? That's why I am saying red is equal to 0x 0, 1 in my program here. So here I'm saying red is equal to 0x 0, 1. In the same way, when I need to write when I need to blink the green LED, only green LED, then I set 0 at all other locations, all other bit locations, 0, 0, 0, 0, 1, and then 3 zeros, right? So this becomes in hexadecimal form, it's become 0x 10, right? So that's why in my program I have written green is equate green to 0x10. And now and yeah, let me move a little bit. Yeah, now if I want to uh, turn on or blink only the yellow LED, then I need to write 0, 0, 0, 0, 0, 1, 0, 0, which is equal to 0x20 in hexadecimal form. And that's why in my uh, code I'm saying equate yellow to 0x20. And when I want to blink all of them, then I need to write 1 on all of them, right? So in that case, my binary that I need to write will be 1 0 0 0 1 1 0 0, which is equal to 0x31. And that's why in my code I have defined 0x31 as I have equated all to 0x31, right? So now, having explained that, now let's go how we are going to write our blink LEDs function in that assembly. So in the text section, we have defined a global symbol blink LEDs so that this function becomes visible to the other file lab3_.c. And then first what we need to do is that before remember that these ports, port B, C, and D on AVR microcontroller, they can be used either as in input mode or output mode, right? So we need to first configure them in what mode we need to use a pin. So if we want to use a pin in output mode, so we need to write to the register 0, which is at address 0x04, which is basically data direction register for port B, data direction register for port B. So what we are doing is that we are saying write all, which is basically 0x31. So we are saying, okay, send write 1 in the bit locations of the data direction register of port B, which correspond to as shown here, which correspond to port pin 0, pin 4, and pin 5. So we are just setting these three pins in the output mode. Okay, and other pins, they are like pins 1, 2, and 3. 1, 2, 3 of the port, they are configured in as input mode. Only 0, 4, and 5, they are configured as output pins. Okay, so after configuring them, so yeah, maybe I can here put the command configure port B 0, port B 4, and port B 5 as output pins, right? After that, what we are doing is that we are defining an infinite loop. So for defining the infinite loop, what I'm doing is I'm putting the value of 1 in uh, R17, and so I'm saying basically R17, put 1 in R17, and then I will simply check if this value is how I'm checking. Let me explain. Let's go down here. At the end, we are saying compare immediate R17 with 1. So check if the value of the R17 register is same as 1. If they are same, then go to this label branch equal. If they are equal, the value is equal, R17 is equal to 1, then branch to the label blink LEDs. So where is this label blink LEDs? It is here. So we will keep, since we are not changing R17, it will always be 1, and always we are testing, is it equal to 1? Yes, the condition will always be true. So it will be an infinite loop. So we'll be going back to this blink LEDs all the time. Okay. So then what we are doing after that, after setting the infinite conditional variable for the infinite loop, we are saying, okay, turn on the LED. So how we can turn on the LED? So here what were we doing? We were setting the mode of the pins. And here we are saying, okay, set all the pins, turn on all of the pins. Let's say instead of turning on all of the pins, I can say, okay, turn only the red pin, right? So when I say here red, so the value of the red is 0x01. So I'm saying write 1 to the pin here. Write 1 on the red LED, right? Send 1 to the red LED. So, and so I'm loading first the value of red in R16, and then I'm writing it to the output pin, right? And after that, I'm saying, okay, wait for some time. Okay. And how long we need to wait? Actually, this is same from the lab one. We are simply having two nested loops. So what I'm doing is I'm putting 255 in R18 register, and then I'm putting 255 also in R19 register. And I'm giving the label outer loop and inner loop. So in inner loop, I have 8 NOP instructions, and after that, no operation instruction. After that, say I decrement R19, which is the condition variable for the inner loop. So after decrementing, I'm saying, okay, if the R19 is equal to 0, is not equal to 0, then go back to the inner loop. So because it is 255, then it will become 254. So it is not equal to 0, we will have another iteration. The next time it will be 253, but it is still not 0, we will have another iteration. So when it finally becomes 0, then the control comes to this next instruction where we are saying decrement R18. What is R18? R18 is the control variable for the outer loop, right? So it was also 255, so it will become 254, but it is not 0, so we'll go back to the outer loop. So in this way, we will have 255 times 255 iterations. And for all those iterations, our LED will stay on. Once we have passed all these iterations, 25 times 25 iterations, we are saying, okay, turn off the LED. And for that, we are saying write zeros, all zeros in the R16, and then write R16 to the port B. Okay. So our red LED, which was earlier 1, it is now set equal to 0 because we were saying write all zeros. So it will turn off. And then we are saying, okay, wait for the same amount of time again. We are doing exactly the same thing, with the only difference that we are using different label names. Previously, the label names were inner loop on and outer loop on, and now we are using outer loop off and inner loop off, and that's it. And after again, so we wait for 25 times 25 iteration, 255 times 255 iterations. And then, so here, this is the condition checking for the infinite loop. So R17 is always 1, we never change it. So we keep doing this in our code, right? Now, yeah, let me first compile the code. Yeah, so we have compiled, and there we see there are no errors. So then we can program, but before that, I need to show my device, my hardware on the camera. How I can show, it's a little bit difficult because difficult to hold. So this is like my this is my hardware, and I'm going to program it now. So when I program it, so you see it says that only a red LED is glowing. Why? Because in my program, I selected a red LED, right? Hopefully you can see my background is blur, but hopefully you can see. And then if let's say I change from red to yellow, and then I download the code again. Now this time only yellow is blinking. Now let's say I change yellow to green and run my program again. So only green is blinking. And now the last test, let's say I set it to all and run it again. So all three are blinking. Maybe the red is not that much visible. I don't know why, but it is blinking. All three are blinking. Okay. So this is the way, this is what you need to do for your task C. So you need to show your work to the two TAs. You need to show your program. You need to show them that your LEDs are blinking. You can select all of them one by one, like red, yellow, green, and all, as I showed you, to get your scores. And also you need to upload your code, your files. Otherwise, you will not be able to get any points. Okay.